In this video, we're going to review the final exam for Calculus 1. The final exam, of course, is Wednesday, May 11th from 8 o'clock to 10 o'clock in the morning. And what you see on this review for the final will be similar to the final exam, which is on my math lab as well. Okay, so we'll start with problem number 1. Here we're going to use the graph of h in the given figure to find the following values if they exist. So in part A, we got h of 2. So here's the graph of y equal h of x right here. And we're finding in part A, h of 2. So that means we want to find out what the value of h of x is when x is equal to 2. So here's 2 right here on the x-axis. And then we go up to this point right here. The corresponding y value for that would be 8. So that means here h of 2 will be equal to 8. Okay. Right, part B is finding the limit of h of x as x approaches 2. So we got to look at the value where we have to find out what value is this function approaching on the left side and on the right side of 2. So here's 2 right here. As we approach 2 from the left, it's approaching this number, 6. And if we look on the right of 2, h of x will be approaching 6. It will not reach 6, but it's getting closer and closer to 6 on the left of 2 and on the right of 2. So the limit as x approaches, well, as x approaches 2, the limit of h of x would be, in this case, 6. Now, part C is h of 7. All right, so let's find 7. That's between 6 and 8, which is that x value here. Notice that there is an empty circle for x equals 7. That means that the value here at x is equal to 7 is undefined. So that means h of 7 is undefined. Now, part D is finding the limit of h of x as x approaches 7. Now, this one's a little bit different here because if you look at the graph, we need to look at where it's approaching, what value is this getting closer and closer to as we let x approach 7 from the left and from the right. From the left, it's approaching 1. And on the right of 7, it's also approaching 1. So we can say here the limit as x approaches 7 of h of x will be 1. Now it would not be 1 because of course, at x equals 7, h of x is undefined, but it's getting closer and closer to 1 as we let x approach 7 from the left and from the right. And part E, the limit of h of x as x approaches 8. Okay, so here, well, that's simple right here because at 8, that value there is 2. And if you look to the left of 8, it's getting closer and closer to 2. And if you look at the right of 8, the right side of 8, it's getting closer and closer to 2. So here, the limit of h of x as x approaches 8 will be 2. Okay, so all of that was problem number 1. Let me check off that circle. All right, problem number 2. Again, we're going to find the following limit or state that it does not exist, like the limit of negative 8x plus 4 as we let x approach negative 2. Well, here we just got a polynomial function. In fact, we have a linear function to be more precise. So that means we can apply direct substitution here. That means I can go ahead and substitute the x with -2. So this will be -8 times x, which is -2, plus 4. Now, -8 times 2 will be 16. And then 16 plus 4 ends up being 20. So the limit as x approaches -2 of -8x plus 4 ends up being 20. So with that one, we just applied direct substitution because it is a polynomial function, or to be more exact, a linear function. All right, now problem number 3, we got the limit as x approaches -5 of x squared plus 9x plus 20 divided by x plus 5. And we want to find its limit. Now, if we were to do the direct substitution here, by replacing the x with -5, we would get a 0 in the denominator. So when direct substitution doesn't work, then another option would be to factor and divide out any common factors if necessary, or rationalize the numerator or the denominator and try to divide out any common factors if necessary. And then if direct substitution works, use it. In this case, we can factor x squared plus 9x plus 20. So I'm going to bring over the limit as x approaches -5, and then factor x squared plus 9x plus 20 into 2 binomials here. Now I still have the x plus 5 in the denominator. So in this case, here, x squared plus 9x plus 20, x squared, I can factor x and x. The middle term and the last term are plus. And then factors of 20 that give me 9x will have to be 5 and 4. And then next, you can see that I can divide out the x plus 5. So I will end up with the limit as x approaches -5 of x plus 4. Now I can apply direct substitution here by replacing that x with -5. So I have -5 plus 4. It'll end up being -1. So in this case here, the limit as x approaches -5 of x squared plus 9x plus 20 divided by x plus 5 will end up being -1. For this, I had to factor and divide out any common factors, and then I can apply direct substitution. So my final answer today will be just this, -1. All right, take a look at number 4. Let's say I want to find the limit as x approaches 36 of the square root of x minus 6 divided by x minus 36. In this case, direct substitution would not work here because I have a 0 in the denominator. So since I got the square root of x and then minus 6, I would rather rationalize the numerator in this case by multiplying the numerator and the denominator by what they call the conjugate. And that is, I just change that minus sign to the opposite, which is a plus. So I'm going to be multiplying the numerator by the square root of x plus 6 and the denominator by the square root of x plus 6. Now, the reason why I'm doing that is this. In the numerator, I'm going to have a difference of 2 squares. A sum and a difference of 2 squares, which means I can square the first term, which is, of course, now I'll just bring the limit as x approaches 36. I square the x. I square the square root of x. When I do that, it wipes out the radical. So I'll be left with just x, and then minus the square of the second term, 6 times 6, which is 36. Now you could for the numerator out if you want to, but pretty much you're going to see with the sum and the difference of the same two terms, you just square the first term and then minus the square of the second term. It's always going to be that. The denominator, I'm not going to multiply that out. I'll just bring that over as x minus 36 times the square root of x and then plus 6. You're going to see that x minus 36 divides out in the numerator and the denominator. So here's what I'm going to be left with. I'm going to bring over the limit as x approaches 36 of, and I'll have a 1 in the numerator divided by the square root of x plus 6. Now I can use direct substitution because I'm not going to have a 0 in the denominator. So I'll have 1 over the square root of x, which is 36, plus 6. And of course, the square root of 36 is 6. So I have 1 over 6 plus 6 ends up being 112. So the limit of the square root of x minus 6 divided by x minus 36 as we let x approach 36 will end up being 112. And of course, in this case, they want the exact answer, so do pay close attention to what they asked for in my math lab. Okay, now problem number 5. Here we got the limit as x approaches negative infinity of 4x cubed minus 6x squared plus 1. All right, in this case here, we're letting x approach negative infinity. That means we're letting x get smaller and smaller and smaller. If we look at just this leading coefficient, which is 4x cubed, that would tell us where the limit of this function will be going to as we let x approach infinity, negative infinity in this case. Here we got a exponent that's odd, an odd exponent. That means this will be going to negative infinity. So that means that the whole thing will be going to negative infinity. Okay, so all we have to do there is just look at the leading term here. That will tell us whether it's going to positive infinity or negative infinity. So for an odd exponent with a negative, where x approaches negative infinity, it will have to go to negative infinity. And sometimes doing the graph of that function will help you determine what's happening when you let x get smaller and smaller and smaller. It's going to get to negative infinity in this case. All right, take a look at example 6. Say I want to evaluate the limit, well, problem number 6, I should say, evaluate the limit as x approaches infinity of f of x and the limit as x approaches negative infinity of f of x for the following function. In this case, as f of x is equal to 12x squared minus 7x plus 9 divided by 3x squared plus 2. All right, and we're going to use either infinity or negative infinity where appropriate, and then give the horizontal asymptote of that function, if there is one. All right, so let's say if I wanted to take the limit as x approaches infinity of that f of x function, 12x squared minus 7x plus 9, all divided by 3x squared plus 2. Now to do that, we will divide each and every term in the numerator and the denominator by the highest exponent in the denominator. In this case, the highest exponent is 2. So we're going to take the limit as x approaches infinity we'll take 12x squared, divide that by 3x squared, minus 7x, divide that by 3x squared, plus 9 divided by 3x squared. The denominator will be divided by 3x squared as well. All right, and in this case here, 12x squared divided by 3x squared would leave me with 4 minus one of the x's divides out. I have 7 over 3x plus 9 divided by 3 will be 3. So I have 3 over x squared. All that's divided by 3x squared divided by itself will be 1 plus 2 over 3x squared. And I'm leaving off this limit symbol. I don't know why I'm doing that, but I need to include that as well. This equals, I need to carry over the limit as x approaches infinity. That's going to be very important because the limit of a constant is a constant. But as x approaches infinity, 7 over 3x will be getting closer and closer to 0. And as x approaches infinity, 3 over x squared will also get closer and closer to 0. And 2 over 3x squared, as x approaches infinity, gets closer and closer to 0. So what's going to be left in the numerator is the 4. And in the denominator, I'll be left with 1. So 4 over 1 would be 4. So this is this part right here. The limit as x approaches infinity of the function f of x would be, in this case, 4. Now I got to do the limit as x approaches negative infinity of f of x. And this is the function f of x. But if you know something, if I go through this process as well, as x gets smaller and smaller and smaller, these terms here will be getting closer and closer to 0. So I'm still going to end up with 4 as well. Okay, so in this case here, we can say here that the horizontal asymptote will have to be 4. Because as we let x approach infinity, the function would be getting closer and closer to 4. And as x approaches negative infinity, for that limit, the limit of that function would get closer and closer to 4. So that means that the horizontal asymptote would be y is equal to 4. And if you recall from college algebra, when the highest exponent in the numerator is the same as the highest exponent in the denominator, you can look at your leading coefficients in the numerator and the denominator. This will be 12 divided by 3, which will give you 4. And the equation y equal 4 would be your horizontal asymptote. Okay, that's problem number 6. All right, number 7 is 3 parts. Part A, you're going to use the intermediate value theorem to show that the following equation has a solution on the given interval. And then you're going to use your graphing utility to find all solutions to the equation on that given interval, and then illustrate your answers with an appropriate graph. Okay, so let's start with part A. Here you're going to have to fill in the blank about the definition, or actually what the intermediate value theorem says. All right, now, the intermediate value theorem states this: if f is, now here they're going to give you a drop-down menu to select your answers. But here, if f is continuous on the interval, and if it's continuous, we have to use the closed interval, a, b. And capital L is a number strictly between f of A and f of B, then there exists at least one number called C in the open interval A comma B, satisfying f of C equals to L. And you might need to look back over your notes regarding the intermediate value theorem to get an idea of what that means, what that statement says here, because all you're doing there here is filling in the blank of this statement. And now we're going to use that intermediate value theorem to answer the rest of these questions here. Like, for which values of x is the function f of x is equal to x cubed plus x minus 3 continuous? And also they do give you the open interval 1, 2. So that's going to be very important here. Well, this is a polynomial function. So that means here that any x value that you assign to it, you're always going to get an f of x value. Okay. And also any x value within that interval, open interval 1, 2, has an f of x value for it as well. So for all x, it's going to be continuous for this function. And also they tell you to evaluate the function f of x at the left endpoint and at the right endpoint. All right, so in this case here, my open interval that I was given is 1, 2. So my left endpoint would be 1, the right endpoint would be 2. And here, the function f of x is equal to x cubed plus x minus 3. So for f of 1, I just substitute each x with 1, so it'll be 1 cubed plus x, which is 1, minus 3. 1 cubed will be 1 plus 1 minus 3. 1 plus 1 will be 2. 2 minus 3 ends up being negative 1. So the value of the function at the left endpoint would be negative 1. The value of the function at the right endpoint, well, my right endpoint is 2. So f of 2 is this, 2 cubed plus 2 minus 3. Well, 2 cubed is going to be 8. 8 plus 2 will be 10. 10 minus 3 will be 7. So the value of the function at the right endpoint would be 7. And then they ask the question, why can the intermediate value theorem be used to show that the equation has a solution on the open interval 1, 2? Here's your choices of answers. And if you look at this, it would have to be this, because it says that it can be used because the function f of x equal to x cubed plus x minus 3 is continuous on the closed interval 1, 2, and 0 is in between f of 1 and f of 2. Notice I have a change in sign. The left endpoint gave me a negative value, the right endpoint gave me a positive value. So that tells me that 0 is in between these two. So we can use the intermediate value theorem here. Now in part B, we need to find out what the approximate 0 for this function. This is where we use our graphing calculator for this. So in this case here, all right, so here I'm going to go to y equal to, let me clear this equation out. I'm going to type in that function f of x equal to x cubed plus x minus 3. So in y1, I'll type in the x. hat key, and then the 3 for the exponent. Use your right arrow key to get out of it, plus x minus 3. And I'm going to go ahead and use, press the window key. Now my interval is from 1 to 2 as given in the problem. So my x min will be 1, x max will be 2, y scale will remain at 1. And I'm going to let y min be let's just do this from -80 to 80 and then hit graph. No. Okay, that's not going to work. Let me change my window. Sometimes, well, sometimes it doesn't, sometimes it does work and sometimes it doesn't. Let's try -10 to 10. And again, sometimes you just got to play around with these things here. Okay. So you can see where the point of intersection where this graph is crossing the x-axis. Let's find out what that 0 is. To do that, you always press second and trace for the calculate menu. We're finding the 0, so we're going to select number 2 for 0. Now for the left bound, I want that cursor to be below that x-intercept. Like I have here, I'm using my left arrow key. You want the cursor for the left bound to be below that x-intercept. And then you press enter. For the right bound, you want the cursor to be above that x-intercept like I have here, and then press enter. And then after guess, you can press enter, and that will give you the 0. And to 3 decimal places as indicated here, it will be 1.213. So x is approximately 1.213. Okay, and then in part C, they tell you to choose the correct graph below. And here they give you the window setting from 0 to 3 in increments of 1, and then from -10 to 10 in increments of 1. So if I go back to my window, let's change that x min to 0, x max to 3, the x scale will be 1, which is this right here. And then the y min, -10, y max is 10, the y scale is 1. So here's a better looking graph. So you can see here, you just choose the graph that best fits the one that you have in your screen, and it will have to be graph B. So you'll select answer B. And here they do give you the dimensions here. This one is for the X, and this one is for the Y. X min, X max, X scale. Y min, Y max, Y scale. All right, so that's problem number 7. Problem number 8 is, as you can see with problem number 7, they do give you the choices there. All right, problem number 8 is finding the derivative of the following function. In this case, g of t is equal to 18 times the square root of t. And here I want to find out what g prime of t is going to be. Well, 18 is the constant. I can bring that over. Now, if you recall, the derivative of the square root of t, or even the square root of x, it's going to be 1 over 2 times the square root of x. So the derivative of the square root of t is going to be 1 over 2 square root of t. Okay, that's just one of those derivatives where you just have to know what it is. I mean, you can write the square root of t as t to the 1/2 and apply the power rule for that. Okay, So if I did that, I'll write this as 18 times t to the 1/2, because the square root of t in exponential form would be t to the 1/2, and then apply that power rule. Bring the 18 down, bring down the 1/2, copy the t over to the 1 less power, which would be negative 1/2, 1/2 minus 1. And then half of 18 will be 9. And then that'll be divided by that t to the negative 1/2 will be in the denominator. So this will end up being 9 over the square root of t. So for here, that's just one way of doing it. The other way was this. I'll finish this out by saying that 2 goes into 18 9 times. So the 9 will be in the numerator, and square root of t will be in the denominator. So these are just two different ways of getting that derivative. All right, number 9, f of x is equal to 10x cubed minus 24x plus e to the second. Okay, in this case here, we want the derivative, so f prime of x would be this. Here we're going to apply the power rule on the first two terms here. For this one, we bring the 3 down, multiply it by 10, that will be 30. Copy the x over to the 1 less power. 3 minus 1 will be 2, minus the derivative of 24x would just be 24, but for e to the second is actually a constant, and the derivative of a constant is 0. So that means that f prime of x would end up being 30x squared minus 24. And I will go no further than that. All right, number 10. We're going to find and simplify the derivative of this function, f of x is equal to 2x cubed times the quantity 6x squared minus 1. Now, there are two ways you can do that. You can distribute the 2x cubed over the 6x squared minus 1, and then take its derivative, or apply the product rule. And here the product rule is just this. The first term is 2x cubed. We copy the first term times the derivative of the second term. The derivative of 6x squared minus 1 would be 12x, plus the second, which is 6x squared minus 1, times the derivative of the first. The derivative of 2x cubed would be 6x squared. All right, so simplify this. 2 times 12, that's going to be 24. X cubed times x will be x to the 4th. Then if I distribute that 6x squared over the 6x squared minus 1, 6x squared times itself will be 36 x to the 4th minus 6x squared. And then combine like terms, 24x to the 4th plus 36x to the 4th will be 60x to the 4th. Minus 6x squared. And that would be the derivative of f of x. And again, you can use the distributive property by multiplying 2x cubed times everything in the parentheses, and then apply the power rule by taking the derivative of each and every single term. All right, number 11 is finding f prime of x using the rules for finding derivatives. Here we got f of x is equal to 4x squared minus 7x plus 9 divided by 2x plus 3. In this case here, we have a numerator and a denominator. That means I can apply the quotient rule for this. So the quotient rule is going to be this. So here, f prime of x would be equal to this. I take the denominator, which is 2x plus 3, times the derivative of the numerator. The derivative of 4x squared minus 7x plus 9 would be, in this case, 8x minus 7, minus the numerator, which is 4x squared minus 7x plus 9. Notice I'm putting that in parentheses, times the derivative of the numerator, which is, in this case, the derivative of 2x plus 3 would just be 2. All that's divided by the square of the denominator. That's 2x plus 3 quantity squared. Okay. The quotient rule is this: denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of your denominator. Now let's simplify this. I have to use the FOIL method here. So I have to do 2x times 8x, that's 16x squared. 2x times minus 7 will be minus 14x. 3 times 8x will be plus 24x minus 3 times 7, which is 21. And then I'm going to distribute the negative 2 over 4x squared plus 7 minus 7x plus 9. Well, minus 2 times 4x will be a minus 8x squared minus 2 times 4x squared. And then minus 2 times a minus 7x will be plus 14x. And then minus 2 times 9 would be minus 18. All divided by 2x plus 3 quantity squared. Let's see, minus 14x and plus 14x, that's gone. And then I got 16x squared minus 8x squared. That will be 8x squared. And then I'm left with a plus 24x, since the minus 14x and plus 14x will give me 0. Minus 21 and a minus 18 will be minus 39. All that's divided by 2x plus 3 quantity squared. And I will go no further than that. So that will be the derivative, or what f prime of x will be. Question, if you have questions, reach out to me by email if necessary. All right, number 12. Let's find dy dx for the following function: y equal 3 sine of x plus 5 cosine of x. So do be familiar with the derivatives of your trigonometric functions here. All right, so if we got y equal 3 sine of x plus 5 cosine of x, then dy dx would be this. The derivative of the sine is the cosine, so I have 3 times the cosine of x plus 5 times the derivative of cosine of x, if you recall, negative sine of x. Now, if I simplify this, this will end up being 3 cosine x, and then that minus will make, that negative sign will make the plus sign minus 5 sine of x. And that's all there is to it. All right, number 13 is finding the derivative of y equal 5 secant of x plus the cosecant of x. Okay, so in this case here, this goes back to your derivatives of trigonometric functions here. So in this case here, dy dx is this. Bring down the 5 and take the derivative of the secant of x. That's going to be secant x tangent x plus the derivative of the cosecant of x. That's going to end up being negative cosecant of x times the cotangent of x. So you might need to look over your notes on those 6 trigonometric functions and their derivatives here. Okay. So if I simplify this, I can just write 5 secant of x, tangent of x without the parentheses. This negative will make that plus or minus cosecant of x, cotangent of x. So that's problem number 13. Taking the derivatives of your trigonometric functions. All right, problem number 14 is one of those derivatives as rate of change here. Suppose the position of an object moving horizontally at after t seconds is given by the following function s is equal to f of t, where s is measured in feet with s greater than 0 corresponding to positions right of the origin. Okay, so here this one has 5 parts to it. And our function in this case is f of t is equal to 24t minus 4t squared, and the interval that they give us is t is going to be time between 0 and 8 seconds. Part A is to graph the position function, and we're going to choose the graph below. So here is where we use our graphing calculator to do that. And notice that we pay close attention to these, to our y, the y-axis, the values on the y-axis, and the values on the x-axis. So let me go to y equal to and clear this equation out, and I'm going to enter that 24t minus 4t squared. And the t, I'm going to replace that with an x. So this will be 24 xt theta for the x minus 4 xt theta for the x, and then square it. Let me go to window. Notice on the x-axis is going to be from 0 to 8. So my x min will be 0. X max will be 8. The x scale will remain as 1. Now I'm going to try for the y min negative 40. And then y max will be 80. The increments or the y scale, I'm going to let that be 20. And then press graph. This is what the graph looks like. And here we want to find out which one matches this. Which one of these matches that? And it looks like graph D would match this graph. Okay, so we're going to use graph D. We'll select graph D as our answer. All right, now part B is finding and graphing the velocity function. And then we ask ourselves, when is the object stationary, moving to the right and moving to the left? Okay. Since this is our function up here, b of t is the same as taking the first derivative, f prime of t. So if f of t is 24t minus 4t squared, and I'll write that over here. We just need the derivative of that. The derivative of 24t would just be 24, minus the derivative of 4t squared would be 8t. So that would be our velocity function there, 24 minus 8t. And now we're going to graph this on the calculator if we want to, because it's going to be a straight line. Let's go to y equal to. Now I'm going to exclude that equation in y1. So what I'm going to do is use my left arrow key to put it over the equal sign and press enter. All right, so that graph will not be included. So now y2, I'm going to type in this function right here, 24 minus 8t. So it would be 24 and then minus 8. And I'm going to treat the t as an x. And I'll do the graph. And that's what the graph looks like. It's going in the downward direction because my slope is negative. So I would expect for that to happen. Now let's select the graph that best fits the one that I have on the screen. Well, if you notice, it's crossing the x-axis, in this case here at 3, so we'll have to be answer A. It can't be B or D because notice that the line is rising from left to right. The one that I have here is falling from left to right. And it can't be C because notice it's crossing the x-axis at 0. So it must be answer A, excuse me. Now let's find out where the object is stationary. All right, when it's stationary, that means that the velocity has to be at 0, okay? So I'm gonna write off to the side here for stationary. That means v of t must be equal to 0 because it's not moving in any direction. And v of t was at 24 minus 8t. That's going to be equal to 0. Now, if I move that minus 8t over to the other side, it'll be positive. So it'll be 24 is equal to 8t. That would mean t has to be equal to 3. All right, so at time equaling to 3, the object will be stationary. All right, and then next, the object is moving to the right. If it's moving to the right, that means v of t has to be greater than 0. So I'm going to put the word right for moving to the right. That means v of t is greater than 0. And v of t in this case is 24 minus 8t. It's greater than 0. So we want to find out what values of time would satisfy this inequality. Let's move the 24 over to the left side. This will be negative 8t is greater than negative 24. But if I divide both sides by negative 8, this inequality symbol changes from greater than to less than. 24 divided by negative 8 would be 3. So the interval that they're looking for, if t is less than 3, and our restriction is from 0 to 8, that's our restriction is indicated in the original problem from 0 to 8. 3 cannot be included, so we know we need a right parentheses there. And 0 is the least it would be, okay? So from 0 to 3, not including 3, and this will be the interval that they're looking for. That object is moving to the right. And by looking at this graph here, so if I bring that up, you can see that it's going to be moving to the right because it's positive and it's above the x-axis. So from 0 up to 3, it's going to be, the object will be moving to the right. Now the object moving to the left means that your velocity has to be less than 0. That means v of t will be less than 0. And v of t is still 24 minus 8t is less than 0. If I move the 24 over to the right side, so it'll be negative 8t is less than negative 24. But of course, when you divide both sides by negative in an inequality, this changes from less than to greater than, in this case, 3. So any t value greater than 3 up to 8, that means the object is moving to the left, okay? Now keep in mind 3 is not included because that 3 is stationary. So anything bigger than 3 up to 8 means that the object is moving to the left. And here they're asking for the interval notation here because of our restriction here, with our time being between 0 and 8 inclusive. All right, next is part C. The velocity of the object at t is equal to 1. Well, since v of t is equal to 24 minus 8t, at time t is equal to 1, we just replace the t with 1. So it'd be 24 minus 8 times 1. 24 minus 8 will end up being 16. Now, they also want the appropriate units there in the drop-down menu. We're dealing with, in this case here, the position, I think it's in feet. Yeah, in feet, and then time is in seconds. S is measured in feet. So the velocity will be in feet per second. Okay. Yeah. So we have to select something like this, feet per second. Velocity is always in feet per second. And now the acceleration at t is equal to 1, right? The acceleration, and I might need to do this on a separate sheet of paper because I don't have any space on my review sheet. Let me write v of t is equal to 24 minus 8t. Because a of t is taking the derivative of your velocity function or the second derivative of your position function. So if my velocity is 24 minus 8t, then the acceleration, we just take the derivative of this. The derivative of 24 is 0. The derivative of negative 8t will just be negative 8. Okay, and they ask for the acceleration of the object at t is equal to 1. So that means a of 1, well, it's a constant, so that means it's still going to be negative 8 because the acceleration, if you graph it, is going to be a straight line. So any x value, any value of t will still be negative 8. So a of 1 would just be negative 8. Now this time, acceleration will have this unit, feet per second square. Since velocity is feet per second, the acceleration would be feet per square second. And then the acceleration of the object when its velocity is 0. Okay. In this case, that means v of t has to be equal to 0. And this is our velocity function here. V of t is equal to 24 minus 8t. So that means v of t was replace that with 0, and that's set equal to 24 minus 8t. Now we want to find out what t is going to be equal to. Well, if I move that minus 8t over to where the 0 is, this will be 8t is equal to 24. That would mean t is equal to 3. So we're going to use that time equal to 3 to find out what the acceleration of the object will be. Okay, well, a of t is equal to negative 8. That would mean a of 3 will still be negative 8. And it's going to be negative 8 feet per square second. All right. And then part E is the speed is increasing on the interval. All right, if you recall, speed is actually the absolute value of f prime of t, which is actually the absolute value of your velocity function. And that prime of t was 24 minus 8t. So here we got the absolute value of 24 minus 8t. And this I'm going to graph on the graphing calculator. All right, so I'm going to go to y equal to. Let's go ahead and take this off, or turn that off, that y2 equation. And for the absolute value, you press the math key, go to the number menu, select number 1 for absolute value, and then type in 24 minus 8, and I'm going to let the t be x. Okay. And then I'm going to press graph. So as you can see here, the speed is increasing. That means it's going up. Now from 0 to 3, the speed is declining or decreasing. But from 3 on up to 8, since our restrictions from 0 to 8, from 3 on to 8, you can see that the speed is increasing. So from 3, not including 3, up to 8, but we do include 8, the speed is increasing. Okay. All right, on the next page, problem number 15. Here we're going to calculate the derivative of the following function. And in this case here, we're going to do, we have the y equal the sine of the quantity 7x to the 4th plus 2x plus 8. This one we have to use the chain rule for this particular problem here. So dy dx would be equal to the derivative of the sine is the cosine. So that's cosine of, and then we copy this argument over. And this is where we have to apply the chain rule. We got to take the derivative of 7x to the 4th plus 2x plus 8. The derivative of 7x to the 4th will be 28x cubed plus the derivative of 2x will be 2. Okay. So I'm going to put the 28x cubed plus 2 in front of the cosine of 7x to the 4th plus 2x plus 8. Now, I'm not sure if they want you to do this, but they might want you to go ahead and factor out 2 in 28x cubed plus 2. And then you'll be left with 14x cubed plus 1. And that's multiplied by the cosine of 7x to the 4th plus 2x plus 8. Okay. All right, problem number 16 is using implicit differentiation to find dy dx for that equation. And in this case here, we got our equation 7x cubed plus 3y cubed plus 10xy. And in this case, I'm going to need to do this on a separate sheet of paper. If you would call implicit differentiation, anytime you have a y, you take a derivative of y, you have to include dy dx. All right, so for 7x cubed, its derivative would just be 21x squared. But for the derivative of 3y cubed, the derivative of 3y cubed, we bring the 3 down, multiply by 3 will be 9y squared, but we need to include dy dx. And this should be an equal sign here. Sorry about that. And then that's going to be equal to that 10xy. When we take the derivative, we have to use the product rule. So this will be the first at 10x. I'll bring that down. Times the derivative of y will be 1. Well, we need to include dy dx since we're taking the derivative of y plus y times the derivative of 10x. That'd just be 10. And I'm putting the 10 in front of the y. Now I'm going to group all the terms that have dy dx in it. And all the other terms will go to the opposite side. So I'm going to leave the 9y squared dy dx on this side. Move that 10x dy dx over to the left side. It'll be minus 10x dy dx. That's equal to, let's see, I'll keep the 10y, but I'm going to move that 21x squared over to the other side. Okay. Now I'm going to factor out the dy dx. Okay, I'm going to factor out that dy dx. I'm going to pull the dy dx out in front. I'm factoring that out. I'll be left with 9y squared minus 10x. That's equal to 10y minus 21x squared. Okay, so to solve for dy dx, I'm going to divide both sides by 9y squared minus 10x. So dy dx will be equal to 10y minus 21x squared divided by 9y squared minus 10x. Okay. So that would be the derivative of that equation using implicit differentiation. Okay. So that right there is problem number 16. All right, problem number 17 is using related rates. So this is a related rates problem. A spherical balloon is inflating with helium at a rate of 400 pi cubic feet per minute. How fast is the balloon's radius increasing at the instant the radius is 5 feet? So here they're going to have you fill in these spaces. One, you're going to write an equation relating the volume of a sphere, V, and the radius of the sphere, which is R. So in this case here, this is one of those equations where you have to know some geometry. The volume of any sphere is always going to be this, 4/3 pi times a radius cube. So that's going to be this part right here, and we're using pi as needed. So the volume of a sphere is going to be 4/3 pi r cubed. And then the second part is to differentiate both sides of the equation with respect to t. So anytime you do a related rates problem, you're always going to differentiate each variable with respect to time. So the derivative of v would be dv dt. That's equal to, now 4/3 pi is a constant, so I'm going to bring that down. Take the derivative of r cubed. That's going to be 3r squared times dr dt. Now, if I simplify that, the 3's divide out in this case. So I have 4 pi r squared dr dt. So that 4 pi r squared would be going in that space there. They already give you the dv dt and then dr dt. Now we want to find out the rate that the balloon's radius is increasing. Now let's look at what we're given here in this problem. We are already told that the balloon is inflating at a rate of 400 pi cubic feet per minute. So let me write this down. R is equal to 400 pi cubic feet per minute. No, I'm sorry, dr dt, because it's a rate that the, take that back, the rate, that's the volume. Okay, I apologize for that because the volume is increasing at that rate. So it's actually dv dt, not dr dt. Dr dt is what we're trying to find. How fast is the balloon's radius increasing? So dr dt is what we're trying to find. And that's at the instant that the radius is 5 feet. And our radius is 5. So all we need to do there is just substitute in this. dv dt is 400 pi cubic feet per minute. So I'll just do 400 pi is equal to 4 pi times the radius, which is 5. That's going to be squared times dr dt. Now, if I square the 5, that's 25. 25 times 4 pi would be 100 pi. So it'd be 4 pi equaling to 100 pi dr dt. And then I need to divide both sides by 100 pi. So that means dr dt, well, 400 pi divided by 100 pi would be 4. So in this case here, the rate has to be in feet per minute. Okay. Since the radius is in feet, the time is in minutes, so it's got to be feet per minute. So the balloon's radius is increasing at a rate of 4 feet per minute. And you do have to select the correct units or the correct rate. Okay. All right, so that's problem number 17. There is a part 2 to this video. So do be on the lookout for that. I will complete the remaining 11 problems from 18 to 28. Okay, so do be on the lookout for part 2 of this video.